Okay, so here's our second thing we're going to take a look at, and we're going to talk about distributions. And what is this device we have here?
It's like sort of like a pinball machine. So all the little beads start from the top.
Sure, you can move it.
So let's reset it. So all the little metal beads start at the top, and then if you do it like this, they all come down and they fill up in these individual slots. And then the yellow line is where what it's expected to look like, and then I think the red lines in the back are the individual outcomes for each.
Yeah, it looks like we got a bunch in there. Did something happen where those caught?
No, I don't think so.
Oh, sorry. From where it was just a shadow from where I was. Okay, so well, tell me about what you see here first.
Well, when you start up here, each ball hits these little pegs and bounces either left or right. So it's kind of expected that you're gonna have more in the center because it's easier to get to the center and it's harder to get kind of to the edges.
Okay.
And this curve is called a normal distribution, and this kind of tends to show up whenever you do anything involving probability.
Okay.
Like repeated trials.
Right. Yeah. So this is actually called a normal distribution. So you've actually heard that word distribution before. Okay. So what do you see on this?
Well, yeah, see, like, there's a low probability of the beads actually reaching the outside because you have to, like, get all the bounces either to the left or to the right. And it's just, it would be easier to just kind of, if you hit this one, then it would be natural to go left than right. And then getting those unnatural bounces would put you toward the left or to the right.
Okay.
Sort of expected to go to the center.
All right. So now we're not going to move this around anymore, but instead I'm going to zoom in on the bottom. Okay. So that's pretty good. Tell me what you think the distribution is here. So we're talking about this new term, distribution. And what do you think the distribution is here? So last time we had these sort of single dots that we put in places. Where's the distribution here?
Well, each of the individual slots represents a number, and they're ordered. They would be ordered from like 1 to however many there are, and then how many dots are in each one represents the probability out of the total number of dots.
Okay, yeah, that's a great way of thinking about it. What would you say?
So I'd say each slot, each height of the bead tower in the slot is our distribution, and each individual slot is a different category. Like maybe we could say, like maybe the probability of flipping all heads or something on however many coins we have here.
Yeah. All right, interesting. So even though it's not me in camera, I'm going to flip it one more time. Does the same thing happen every time?
It doesn't, no.
Okay, why? Why not?
Well, sometimes it shouldn't be like that because the beads will like rush out differently. They will like bounce off other beads and hit differently. And you can see in this one there's a few that this one's above where it's expected to be by a lot actually.
Okay.
And this one is below. You can
Yep.
see it's actually sort of shaped like that. And overall it's going to all be shaped like that.
Yeah, and I don't know if that yellow curve that we're seeing will show up as yellow on the screen, but there is a curve drawn on this that represents the expectation of how they're going to fall.
And they generally follow that curve.
Yeah, so if I want to know the probability of a ball falling into one of those slots, like pick any slot you want, how would I figure out what the probability of a ball being in that slot was? What would you do?
Well, you'd have to measure the number of balls in that slot, and then you have to divide that by the total number.
Okay. Pretty good.
And then maybe repeat that a bunch of times to get a closer approximation to the...
Yeah.
Yeah, no, that's actually a great idea. We could do a bunch of trials. Can you think of any way that you could figure out the probability of a ball being in one of those slots without doing repeated trials, with doing some math maybe that you're studying now?
Well, I'm not too sure how this would relate to calculus.
Okay.
But
Well, what does the area under that yellow curve represent?
that's all of the balls.
Okay. So what is the probability of for the whole being under that curve? The sum of all the probabilities is
That's 1.
That's 1. Okay. So what is the probability of being inside of one of those boxes? Roughly.
Well, I guess you could say that would be the integral from the left line to the right line
Yeah.
of that curve.
Okay. Of the box.
Of the box, yeah.
Yeah. So first off, these approximations look like what sort of thing that you've studied in calculus a little bit?
Riemann sums.
They look like a Riemann sum. Sorry, our cat has decided she wants to be part of the movie. So it does look like a little bit of a Riemann sum. So another way we could figure out the probability of being in one of those boxes is just find the area under the curve inside of that box, that small little region, and then compare that to the whole area. But it's nice, the whole area we know to be
1.
1. So that's one way. That's an interesting way of understanding the distribution, because as you imagine these boxes shrinking to become very, very tiny. Eventually, the probability of being inside of any box is going to essentially be 0. So, but you still have to figure out. But you can figure out the probability of being in sort of an area inside of that, which is what we have here. So that's neat. And then the other thing I want to show you is I'm going to tilt this just a little bit. And what do you expect to see now that I've tilted it slightly that way?
So we should see more than expected on the left side and maybe less than expected on the right.
Okay, did I tilt it enough? Well, a little. Yeah, you can see we got a little bit high there.
Maybe like put a die under it. I don't know.
That'd be a little too much. Yeah, there you
So
can.
it sort of like shifts the curve over a little bit.
Yeah, just a little bit, but I've only tilted it a little bit. But this shows you, previously we saw the uniform distribution and we saw things that didn't have to be precisely uniform with our green die. And as I tilt this, what I was hoping to show you, and I just didn't tilt it enough. Let me get something just a little bit more under here to tilt it. What I was hoping to show you is that we didn't have to have something that was necessarily symmetric here.
Yeah, there we go. You can guess you got a bunch over here and a bunch under on the other side.
Yeah. So you don't have to necessarily be symmetric. It's just all the probabilities have to add up to 1, and then you'll get whatever you get.
Yep.
Okay? So now we're going to take a look at something really neat that I saw yesterday.